possible. I've heard it is from multiple people. Can you do it?
Oh no.
Well, I'm never gonna try to commit suicide ever again. I almost killed myself.
Oh, not smart.
It's that hard. Wait, so you have to multiply to get 13 and like add and subtract to get 40?
Nope, you have to multiply a times c in the modified exponent.
So 39, 40.
Oh, it's easy. I got it.
Yeah, it's not bad at all. 39 and 1, right?
Oh.
Yeah.
Oh,
Yeah.
Friday's been homework soon.
I knew that guy.
Wasn't that bad, was it? 39 and 40?
Oh, that's so easy.
39 and 1.
But wait, how did you factor it?
I just.
You went to grouping? Party pooper. But yeah, grouping works.
No.
Grouping works. If it's your way, go for it.
In this equation.
Yeah.
Caitlin, you should color your nails, not use zip colors. I like pink.
I'll do my nails.
I'm gonna do mine matte black. I'm gonna be Bob.
So pause. Let's recap and review, because some of you are doing this different ways, and the different ways aren't necessarily bad as long as you're getting it right. Right? How many of you, at some point doing a factoring problem, it could have been this one, it could have been other ones, you used grouping? Let me see.
What's grouping?
Grouping was what was on the board yesterday.
Oh, okay.
With the X terms, and then we do the parentheses and what's in common. Okay. So I'd say like half the class at some point use grouping. It's still a fallback, or maybe it's your main way. How many of you guys use the star in some way, shape, or form? Okay, I like it too. It's like the other half-ish. Is anybody using like a grid box thing? Is anybody using the grid box?
What's a group?
Oh, Lucas is? Okay. You do the box with your factoring? Yes, I can.
I have another one.
Let's do a quick review for people who either did do the star. Well, no. People who did do the star. You are using it because you like it, so you teach Nikki how to do it. What do you put where? People who use the star. Okay, so Aiden's saying A times B, so 39 up in the top, and what goes down? B or 40. Now, the question you're asking yourself, Nathan, can you put it in a sentence? What are you trying to fill in? How do you
You're trying to fill in two numbers that, when you multiply them, equal 39, and when you add or subtract them, equal 40.
Which is why on this one we could have gotten 39 and 1. Multiplying to 39, adding to be 40. Now, someone who does the star method, what goes next?
Put a line through it.
A line over the top, that's important. And then what did I put?
You put A.
A. And then what do you have to ask yourself? Can you simplify? Can you, technically I would use the word reduce, right? I can reduce this one. Now wait, how do I get to my answers? The top row are the x's, or the x terms, and the bottom row are their constants, and each one's a pair. So 1x plus 13, 3x plus 1. Been done. Now, Lucas, I know I'm going to stretch you a little bit. Can you try to explain the box to me? I've seen it before. You've made 4, right? Yeah. Okay. What do you fill in where? Do you fill inside first, or do you fill in the outside first?
I fill in the inside first.
Okay, so then what goes in this box?
So 3x.
Yes, Diego, here's another alternate method. Maybe it'll be the same. So you fill in the 3x squared?
Yeah.
Okay, now what goes down here?
13.
Uh-huh. Now what do you do?
I multiply the 3 and 13, and then
Do you do it like off to the side? Like it's probably all mental math, right? Okay.
actually, what I do first is above the 3x squared, I put 3x, and then the left is at 3x, and then I multiply the 3 and 13, and then I get the factors of it, and then
Something similar? So sufficient. Okay. And then you probably put in like, is it the 1x and the 39x?
way around.
The other way around? So my people that do grouping, it's kind of like what grouping does with the X terms. Sorry, keep going, Lucas. Then what?
When I would put 13 or the rest of 39, and I would put 1 above the 1x.
Okay. And what he's doing is, in a sense, the 3x is being pulled out from this. Like you're factoring out the 3x and you're left with an x and 13. So 3x and x makes 3x squared. 39x take away 3x is 13. This one, the 3x squared takes out the x, get the 3x. The 1x takes out the x, get the 1. But you kind of get used to it in a sense, like he's not necessarily thinking through that whole process. But there is a way to like put in your first term, put in your last term, try to think off to the side, how can I put in these? And then to get to your factors, it technically, this is a mathematical way of showing what my reducing is doing over here. In the sense that you literally are factoring out from this a 3x, or factoring out from this an x, factoring out from this a 13, or factoring out from this a 1.
Can we do another one on the board so that we can try
Of the box?
Yeah, I
You want to try the box?
Oh.
Yes, go for it, Kevin. All right, whatever method you do, get it right the first time, without anyone else telling you how to do it. Whatever method you use. Now, some of you are trying the box just because you're curious. That's totally cool. Then do the X or do grouping and check. So, Kimmy, what do you got?
12x squared plus 43x plus 13.
Man, you were having fun. Woo! All right. Last one.
I give
Last one. Last one. Whatever method. You can use your calculator. Ideally, you wouldn't have to, but. Oops.
It's 12x plus 39.
It's 156, right?
Yeah. Oh, okay, that makes sense.
Oh, everyone's like, that's too complicated. Alright, let's do this.
Are you sure this is possible?
Yeah.
Yeah.
It's possible.
Lucas got it.
I get it. I get it.
Yeah,
Let Lucas come up to the board. We should let Lucas come up to the board.
Wait, let Lucas do
Let
it.
Lucas come up to the board and do it.
4 and 39.
He already had to explain it out loud.
Okay, so you erase the 156 and you put a 13.
Yeah, erase the 156. In the box. In the box and put a 13. Yeah. Put a 13.
Wait, I thought he put the factors of 156.
I know.
Did not 156.
No, it's 39.
Okay, and then since it's 12x, we should put factors in 12x. So you put a 3x on top of a 3x on top of the 12x. A 3x up there, and then a 4x up there. Yeah. And then a third.
You find the factors of
the factor of the
156.
13. So you bring the 13 over to the right. Or to the left. So you put the 13 to the left. And then a 1 up there. And then you would put a 4x in the top right. And then a 3x in the bottom left.
So no, 13 there.
Yeah, 3x.
Yes, it's good.
And then the answer is 3x plus 1
Oh,
and
4
4x
and
plus
39. I
3.
thought it was 4 and 36. Okay. That makes more sense. Got it. But the way you would probably have wanted to think about that would have been, yeah. You guys were trying to fill in the box weird ways. Would have been to figure this out, and then to write, and then to
Figure out what.
factor out the common 13, and then factor out the is only a 1, right?
It's still a 4x.
4x on the left.
It's either 4x.
Oh, I didn't write the 4. Sorry. Yeah. Oh, the other way? The star, you would have had your 156 with your 4 and your 39, which would have gotten your 43.
Over.
Taking your 12. 3 comes out 4 times 3 comes out 4 times. 4 comes out 3 times.
What's it?
Alright guys, come on, go. That's great. The box is more like how you do it. That makes more sense. I didn't see the 4 and 39. Alright guys, I know. You've had too much fun. Meaning, you're not paying attention when I'm asking you to. Homework open, color pen out. I had a great question. Great question was, what if I didn't get homework done for today? We're going to be like, and then, can you grade it if it's not done?
No?
Yes.
I would say so.
Awesome.
Yes. Oh my goodness, your guys' logic is worse than I thought. Come back. Okay, if you had written it all out, right? Okay. So let's say you shouldn't grade it if it's not done, but all the grading is on the video, so you can watch the YouTube video anytime you're absent or sick, or you just have a late work. You can watch the video later and grade it, because aren't I grading the grading when I collect this homework file? So it has to get done at some point. It doesn't always necessarily have to happen in class 8. As soon as Dylan comes back. For those of you guys real quick with the box, they were helping me in the back as far as I just didn't see 4 and 39, so that was my bad. Just in case you're curious, because I didn't specifically explain it. I had others explain it. You throw your first term up, you throw your last term down, and then you multiply like we've been doing, and technically it would be 156x squared, technically. And that would be a 4x and a 39x, which is what you fill in. And technically it doesn't matter where you fill it in, because all you need to do is basically just ask yourself what's in common. It's like grouping, but it's just shorter. So what's in common between these two coming up is a 4x. What's in common between these two coming over is a 3x. What's in common between these two is nothing, so we put a 1. And what's in common between these ones is a 13. You get your 3x plus 1 and your 4x plus 13, like your star gets. It's a cool method. It shows the entire process of grouping, just a little bit shorter. But anyway, there's the star, asterisk, whatever you want to call it. There's the star, there's the box, there's grouping. You just need a way that works for you every time, right? Now real quick, we're going to come back for just a second. But didn't we have those impossible factoring ones just a moment ago? So we wouldn't have been able to factor, but I have a quick question for you. Just because it was an impossible, oh, do I still have it? No, I don't. This one was an impossible one. Just because he's impossible, I can't factor him, but can I still find his zeros? He's impossible to factor, but can I still find his zeros? Can I still find his vertex? No. The vertex would be a yes, the zeros would be a maybe. Not all parabolas have zeros. I'm not sure if that was a true or false. It should have been in your homework. That would have been great. Question. Why would or when would a parabola not have any possible zeros? Like not even gross quadratic formula zeros. Not touching an axis. And Kobe, is that enough though? Just that it's in a quadrant, not touching an axis? Yeah, it has to be going, if it's above, it has to be going up, right? And if it's below, it has to be going down. So not touching an axis and never will. Not touching an axis and never will. So there are times when it doesn't have zeros. So the zero thing is a maybe. The vertex thing is a definitely. Everything can go into vertex form. Not everything can go into factored form. But are there times when the zeros are gross? Yes. Can you guys look at the board really quickly at the two impossible problems? Can you tell if either one of them will have zeros? Yes, the top one is very good, that one. But for number 2, it's really good. For number 2 and for number 3, do either of them, we can do vertex, fine. Every quadratic can have a vertex, or has a vertex. Okay, we could use the quadratic formula, right? And if we use the quadratic formula, we can get imaginary numbers. So technically, couldn't you check what we would call, you might not remember this, the discriminant from last year? Remember the discriminant? He's the dude that's under this in the this. Why is he the main guy as far as what to look for as to whether or not the zeros exist?
Because if it's a negative.
Yeah, Kayla's like an I could come out and it's going to happen if there's a negative under there. So all we have to do is really just look at b squared minus 4ac. Is 64 bigger than 4 times 4 times 16? Another way of looking at it is it's all plus, which means everything is plus, everything is up. There's a vertical shift, it's not going to be hitting. It's an upwards parabola. But you would have plugged in and gotten a negative number, so the zeros are imaginary, and guess what? Same thing for that one. But there are nice zeros. Anytime you get a factored form, there are nice zeros. There are ugly zeros that you can get from quadratic formula. Any quadratic can have a vertex, but not every quadratic can have zeros. We need to, I'm going to make calculus notes. Goodness gracious. Great! Section 2.1. And section 2.1 starts with number 4, axis. Number 6, negative, has a maximum. Number 10, matches with letter A. Those were fast, those were quick. Number 24 gets a little bit rougher. You ready? Sorry. 4, axis, 6, negative, leading coefficient, you have a max. And number 10 matches with A. Number 24, there's a lot going on. Did you find it all? Oh, but the factoring was easy. So the zeros were easy, right? The zeros were easy. The vertex, you could have used your starter. First, h equals negative b over 2a, and then plugged in. Or you could have completed the square pretty quickly. For those of you that are mental mathers, completing the square goes faster. If you get it down. If you ever get it down. And then you see the graph, your zeros, boop, boop, and your vertex, boop, and then boop, and it's 8.
I got x plus 8 squared, and then for some reason I got minus 9.
Ooh, okay, let's check it. So when you were completing the square, they didn't show the work super great, right? The leading coefficient of 1, that was already good. We have our x squared plus our 16x, and we have our minus 17. So you did get the 8. So the 16 over 2. Maybe it was, did you put a 64 in this blank?
No.
Okay, that's what it was. So you figured out that it was going to an 8, because I think you figured out the half of 16 thing.
Oh,
But
yeah, do it again. We do
yeah. You see it?
Yeah.
There you go. So you gotta put it here and offset it over here. We're trying to keep everything balanced, and so then we subtract those two to get the 85.
Okay.
Good question. Anything else while I'm on 24? Can I keep going? Okay. Number 54 was a bit of a fraction party. You guys caught that with your calculator, or were you amazing and did it by hand?
I started doing it by hand, then I realized I was wrong.
I think I did
I might be wrong for that.
Good. I'm glad you did that. Did you guys realize that? I mean, some of you liked when they started giving you clues. It was like, haha, I know H, haha, I know K. But then it was like, I don't know. But we did know an X and we did know a Y. So we could go substitute the X and substitute the Y to our snazzy form we were trying to get. That's what's down here. Now, Something that should be easy is hard. Why? Fractions. Why? I don't honestly know. Maybe you have people that don't mind fractions teaching the higher math and not the lower math. I know our math teachers, they don't mind fractions either. It's just, get this thing against them. My calculus kids are bad at fractions. Wouldn't we have to, it's not as hard as it looks. Can I just, get a common denominator and life is better. Can't I just make that negative 4 over 2 minus 5 over 2, right? Can't I do 4 over 1 and make that 16 over 4? That's negative 9 over 2 squared is 81 over 4. Don't go to decimals, it's so much worse. Oh, I can add that 3/4. Look, I'm getting common denominators everywhere I go. Life is so much easier. I'm getting common denominators times 4 over 4 to accept the 3/4 and make it nice and easy. End of the day, I just have to go ahead and multiply by. Get common denominators wherever you go. Any whole number, put it over 1. Common denominators, it goes together so quickly, it squares so nicely. I can multiply by the reciprocal so easily. No decimals are necessary in the making of this problem. Maybe some math students got hurt, but besides that. Get common denominators. Why am I saying that? Because there's another fraction problem coming, unless I skipped it for regular. I don't remember if I did or not. But first, number 58. How'd the factoring go? It was hard. No, it wasn't. Not compared to what Kimia was giving us, right? You have a way to factor. Come on. Now be careful for the zeros. Remember, after we factor, we set each one equal to 0. So that would be a negative 3, and this is a add the 1, divide the 2. That wasn't too bad because we practiced our factoring so much, but okay, this one got a little bit messy.
Whoa. Oh yeah.
You got stuck on 54. There's no way you really tried 76.
I
Well,
wrote down everything. I just did mine.
yours is easier.
What is the?
What's the what?
Okay. Hold on, pause, and take a breath. I'm just curious. All around the room, did anybody try number 76 by hand? Completely by hand?
Yeah, right. Good one.
Now, hold on. Can I show you guys a trick real quick? It's a trick about me, basically, as a teacher and what I expect from you. Okay? I do expect you to be able to do fractions. That's so true. And mental math to either be good at it or work on it and try to get better at it. Even like things like factoring, trying to make you faster. But if there's ever a problem where a decimal ends up occurring, it's a calculator problem. That's something from calculus. If a decimal is occurring, now not a decimal as in the last one, 19 over 81, I could have had a decimal. No. But guys, check out Calc Chat. Now, I get it, you didn't have Calc Chat, I do. But do you see how they have decimals in their answers? If they have decimals, they're using their calculator. If they're using your calculator, well, hold on. Isn't this a downwards facing parabola?
Yeah.
From our Precalc graph and calculator handbook, if they are asking us for what the height is when it was punted, couldn't I just, in my calculator, oh, that's easy. Plug in 0, sorry. Nope, that one should have been easy. Because when it's punted, that's how high it is. Well, it wasn't that high off the ground. You guys know that. That's how high it is when it's punted. You could have just plugged in x equals 0. That one's not too bad, but this one, the vertex, couldn't we have just found the max? They're using their calculator anyway. Now, pause. Does negative b over 2a work? Yes, it does. Could we actually do completing the square? Oh, they didn't even complete the square. They said, forget it. We're just going to do the plug and chug the starburst way. So they found their little, I can't get a yellow very easily, sorry, in this program, but they did their little formula, and then they plugged and chugged, and then they eventually, look at this, all this mental math, and then they give you a decimal. I'm like, what the, I don't even know. And then down here, look, they're giving you decimals. I'm like, you're using your calculator anyway. Why not just find the max for letter B? And for letter C, why not just find the, who's this guy? inner calculator? The length of the punt? Yeah. It doesn't call it that though. Remember what the calculator calls it? Where do we find it? 0. So this could have been your letter C and this could have been your letter B. You're welcome. So, are there times when I want you to be doing the mental math, want you to be struggling through the fractions? Definitely. But if they have a 1.5, like, come on, that should have been 3 halves if you were going to do fractions. I saw the 1.5 and I was like, forget it, you can go to your calculator. But pause. There are times, can we go back to number 54 real quick? There are times when you do not need your calculator. And so you should be struggling through trying to do it by hand. You guys see the difference? This one only fractions, the other one 1.5. Come on. But anyway, end of the day, letter A you get 1.5 feet, letter B you get 104.02 feet, and letter C you get 228.64. I was trying to scroll that. 228.64 feet. But once again, use your max feature and your 0 feature. But will you have to play with your window?
Yes.
Yes, because this is 228. Gotta zoom out at least a little bit. With that, I think we are at the end of our, yes we are, homework. Is there anything you guys want to ask me about that I haven't already covered? Yeah, sorry.
Can you find the zeros by finding the standard formula and then plugging in zeros?
It's just going to look a little differently. I had one in our notes that I did, and I think it was at the end of class real quick. Let me find it real fast. I just want to show you the difference between quadratic formula zeros and complete the square zeros. Because it does end in the same place, but only after simplifying. Oh, right here. So I did it both ways on this one, Sven. I did the quadratic formula on the right. You see it right there, right? On the left, I did complete the square first for my vertex anyway, and then you said set equal to 0, which is exactly what I did. So over here, I got technically -3 plus or minus the square root of 20/3, which if we had rationalized it, that would be -3 plus or minus 3 root 20 over 3. Plus the that would be, I guess, 2 root 5. So that would be 6 root 5. So if I had just done it this way, it would look different than the quadratic formula, but only because I didn't get common denominators and put it all together. So technically, just as I wanted to prove to you guys it was the same thing, I ended up getting my common denominators, rationalizing my denominator, and showing that it really is the same thing. So it's going to look maybe a little different, but if you plug in the decimals, it should match. Yeah. Anything else besides 33, guys? Okay. Do you guys think that I think factoring is important?
Yes.
Okay. And do you guys think that I was a little skeptical as far as your mastery of it coming into my class?
Yes.
Okay. Do you think there was maybe some reason for that?
Yes.
Okay. But hopefully after the last couple days, you have a way that works for you, and if you don't, you're going to come see me, right? This one, they can help me out real fast. What were the directions? Or the point of the
You have to write it in standard form and sketch a graph and then identify the vertex, axis of symmetry, and the zeros.
Standard form, leading coefficient of 1. This is one of those nasty factoring ones where you have to divide by 1/4, which means multiply. Divide by 1/4, which means multiply by 4. Sorry. Remember, you can always double check by making sure your distribution comes back to the original, and 1/4 times -8 does. I take that -8, cut in half, square it, which would be 16. But 16 over 4 is or 4, and I need to offset. At which point I pretty quickly get to my standard form, which I can get there's my standard form. My vertex pretty quickly, x minus h, so +4. Okay, my axis of symmetry, I steal it. my zeros. What would have been really nice if I could factor, which I'm looking at my 16, my 12. Let's see, what would this have been if I could have factored? Because someone, Kimia gave me a 1/4, or someone gave me a 1/4. Who was that? Someone gave me a 1/4, and that would be an x squared minus 8x. I'd have to pull the fourth out of this if I wanted to factor it. So that would have been 48, which 6 and 8, 2 and 24, 3 and 16, 4 and 12. Ah! Maybe wait, 4 and 12 though, yeah? Nice. And then sketching. We could have done quadratic formulas, which would have been gross with the 1/4, or we could have done set equal to 0, which would have been a little easier. You would have gotten the next one. But at that point, I would take my positive 12, my negative 4, and my 4, negative 16. Alright guys, now, if you notice, time is running short. Maybe it was purposeful, maybe it was not, but that was a tricky one for sure. I want to show you where we're going. And I need you guys to do a couple things for me. Because tonight, if I was to say homework, you would be like, oh my gosh. Which is why I'm having you get out your phones right now. I'm going to have you tonight for homework. Get your notes all ready so we can start right away tomorrow. Now, these notes will be online on the video. They will also be saved on the PDF in your shared folder, which is underneath classwork in your Google Classroom resources. So you're taking these 2 pages and just wait, there's 2 more. You guys got it? Yeah. Remember, you can find it in the PDF online also. So I should take those 2. The PDF is online if you want to do it. Just set it up, just get it ready, get the sketches, get the spacing all worked out, because then we're just going to fill in that tomorrow. So if you guys know, the title is Polynomials of Higher Orders. Orders. Okay, hold on, pause. Complete silence for the last however many seconds of class, which is about 35. Polynomials of higher orders. If I change the word order with degree, higher degrees, what am I talking about? Give me an example of a polynomial of a higher degree. Higher than what? Yeah, higher than a quadratic. How about a cubic? How about a quartic? How about a quintic? We have to do intercepts and zeros and factoring and with higher order polynomials. Things like synthetic division will come back. And long division will come back. And finding the possible rational zeros will come back. And end behavior, knowing what's going on at the end. Bye guys. Make your notes tonight. Just no. Bye guys.
Also, I know you